Okay, so today's lesson we're going to be learning about parts of an expression. So first let's define what an expression is. An expression has no equal sign. So we're going to be learning about equations in a little bit. And so equations have equal signs, but expressions have no equal signs. So look here. This is an example of an expression. Notice it has no equal signs. So there's no sides to the equation. It's just one expression. So let's define some terms here. First thing is variable terms. So a variable term is a term with a variable. So 7x has a variable, has a letter here. That's a variable term. Negative 5x also has a variable. And 4x also has a variable. So those are our variable terms. Our constant terms are the terms without a variable. So 3, 8, and negative 1. All of those do not have a variable. Now when I ask for coefficients, that's the number next to the variable. So, for example, 7x, see how there's a number next to that variable right there? That 7 is called the coefficient. So that 7 right there is the coefficient. There's also negative 5x and 4x, and all three of those have coefficients. So 7, negative 5, and 4 are called coefficients. Coefficients are the numbers next to the variables. So let's look at combining like terms. You can simplify an algebraic expression by combining like terms. This means to combine common variable terms and constant terms. So example, simplify the expression below. So we're going to combine common variable terms and common constant terms, okay? So we have 7x, negative 5x, and 4x. All three of those are common variable terms. They have the same variable, which is x, and we just combine the numbers in front. So we're going to say 7 minus 5 plus 4, which is 6x. 7 minus 5 is 2x, right? And then 2x plus 4x is 6x. So we're just literally, you just combine all the numbers in front and put an x at the end. And then we're going to look at our next terms, which are constant terms, the term without the variable. And we have a 3, so 3 plus 8. 3 plus 8 here, that's going to be 11, right? And then 11 minus 1 is going to be 10. So our final answer here is going to be 6x plus 10. So that's simplifying. So let's look at number 1. We have a 3x and a 6x. Both of those are like terms. They're both variable terms. So we have a 3x plus 6. Well, 3x's plus 6x's is 9x's, so 9x. Okay, the next two, 9a minus 10a. Both of those have a's, so we can just look at the number in front. So what's 9 minus 10? That's negative 1. And then just put an a at the, end. So 9 minus 10 is negative 1, and then a. We can also write it as just negative a, because there's like an imaginary 1. Not really imaginary, it's just not, usually, you don't usually write it like this, you usually see it like this. And these both mean the same thing. Okay. Number 3. So for number 3, it says 7m minus 5m minus 6. So our common terms here, our variable terms, 7m minus 5m, and that's 2m. And then I just bring down the minus 6. There's nothing else I can do there. That's all I can do to simplify. Now the common terms here, we're looking at the constants, the one without the variable. So we have a 9 and we have a positive 5. So 9 plus 5 is 14. And notice how I put the negative 6w first. It is, to write it in like a proper standard form for math, we always write the variable part first. So negative 6w, and then 9 plus 5 is plus 14. All right, number 5, we have a 7p and a negative 9p. So 7 minus 9 is negative 2p, right? And then we have a negative 1 plus 5. So negative 1 plus 5 is a positive 4. Okay, number 6, we have 5h plus 7h. 5h plus 7h, so 5 plus 7 is 12h. And then we have a negative 6 minus 8. Remember we have two negatives like that, and we're combining. It's going to be a negative, and we add. So negative 14. So negative 6 minus 8 is negative 14. Number 5. So number 5 has x's and y's. So 5x minus x Remember, there's like a 1 in front of that right there. So just like that a term that we looked at for number 2, you could write this as negative 1x. So if we're doing 5 minus 1, 5 minus 1 is 4. And then 4 plus 3 is 7. So 7x. And then we combined our y terms. So 7y plus 2y is 9y. And then number 8, we have a's and b's. So 26a minus 4a. So 26 minus 4 is 22a. And then 2b plus 10b. Both of them are positive, so we just add 2 plus 10, which is 12b. Okay. Let's look at some with exponents. So terms with the same exponents or combination of variables and exponents are considered like terms. When combined, make sure not to change their exponents. Okay, so do not, so for example, number 9, notice how both of them have x squared. When we add them together, we don't make it x to the 4th, because in the same way, when we add something like 5x plus 7x, isn't that just 12x, right? Did we say x squared when we add them? No, we just keep the x's. 5x plus 7x equals 12x. That's all we do. We do the same thing with x squared. So if we have 5x squared plus 7x squared, that's going to be 12x squared. Okay, here don't change the x squared. Here we have negative 15 and a 4, and both of them have an n to the 5th. So negative 15 plus 4 is negative 11. Oh, I put negative 9. Let's change that. It's negative 11, and then n to the 5th. You always keep the n to the 5th the same. Okay, you keep that the same when you combine like terms when there's an exponent. And remember, an exponent are these things right here. That's an exponent, that 5, and that little 5 is also an exponent. Number 11, so all 3 of them have c to the 3rd power, or c cubed. All 3 of them have that. So we can combine the coefficients. Remember, coefficients is the number in front of the variable. So 8 minus 7 is 1, and then 1 plus 16 is 17, and then we just keep c to the 3rd the same. Okay, here we have k's, k-squareds, and variables. So always look at your greatest variable first. So k squared is bigger than k, right? So let's combine these first. So we have 2 k squared terms, and we have 8 minus 2 is 6 k squared. And then let's look at our k terms. We have a negative 1k. Remember, we can put a 1 in front of that. Negative 1 minus 5 is going to be negative 6k. And then plus 7 at the end. And that's it. So remember 13, remember perimeter? Perimeter, it means to just add all sides. So it says give the perimeter of each figure as a simplified expression. So we're just adding all sides of this triangle. So 2x plus 1, which is right here, we're going to add 2x plus 1, plus x plus 3x, and we're just going to simplify. So we have 2x, x, and 3x. Remember, we can put a 1 in front of that x, so we have 2 plus 1 plus 3. 2 plus 1 is 3. 3 plus 3 is 6x plus 1, and that's it. So same thing for number 14. Now this is going to be kind of a long one. We have k squared minus 9k plus 23 plus k squared plus k plus 2k squared, or no, I added it twice. So this, and then plus 2k minus squared minus 17. And we look for all the k squareds. So we have, I'm just going to add 1s in front of those. So we have 1 plus 1 is 2, plus 1 is 3, 4, 5. So we have 5k squared. And then I'm going to look at all my k terms. So I have negative 9 plus 1 plus 1. So that's negative 7k. And then I'm going to look at all my just regular terms, so the constants without the variables. 23 minus 17, which is a positive 6, and that's your answer. Okay, last one. So here, perimeter, remember, with perimeter, with a rectangle, if this is y plus 2, this is also y plus 2. And if this is 3y minus 5, this is also 3y minus 5. So opposite sides are equal, are congruent. So we could write that twice over here. And now perimeter means add all sides. So we're just going to add all of those sides together. and combine like terms. So 3y plus 1y is 4. And then 5, 6, 7, 8. So we have 8 y's. My goodness, it's wrong too. Okay, hang on. So this is 8. 8y. And then we have a negative 6 because we have negative 5 plus 2 minus 5 plus 2. So if you could just combine all of those, you're going to get negative 6. And that's it. 8y minus 6. So now I want you guys to complete the practice problems.